Welcome to Oak Ridge High School Level Chemistry Reactions, Unit 5, Day 1. We're going to start today with just a few announcements, some things to go over and some things to keep in mind. First, this is a brand new unit, which means we just finished taking our Unit 4 exam. If you did not do well, I strongly recommend that you retake the exam. Before you can retake an exam, you need to complete the remediation assignments, check Canvas for more information, or get in touch with your teacher for my class, Ms. Stafford's class. I'm going to have a remediation assignment available on Canvas for everyone. You will get the higher grade, so if you're not sure if you want to retake it, if you're afraid you might do worse, we do give you the higher grade, so don't let that stop you from doing a retake. We do have a final exam coming up and a 9 weeks exam, so if there was something you didn't understand with that Unit 4 exam, I would very, very strongly recommend that you retake and figure out what those gaps in your knowledge are. The other thing I want to talk to y'all about is the DIY Labs extra credit module on Canvas. I'm going to say it's due by December 8th. Every single one of these that you complete will give you 10 points added to the major grade category, which is huge. So if you did all 10 of them, it's like getting a 100. And these are easy and fun projects like making a volcano, making a mini lava lamp, making rock candy. These are fun hands-on assignments, and all you have to do is post a picture or video of yourself on the Flipgrid. If you need any more information on that, look on that Canvas page and get in touch with your teacher. So, fun way to earn some extra points. Okay, so let's get into our notes. Today, we are going to be learning about identifying reaction types and understanding the law of conservation of mass. So, let's start by thinking about what is a chemical reaction. You might be thinking about that. There's a spot in your notes and you can just write down what you think, and maybe by the end of class it will be different. We've all heard this, so what does it really mean when we say something's undergone a chemical reaction? So here is a chemistry definition. A chemical reaction is when a substance changes into a new one that has a different chemical identity. So it is no longer on a molecular level the same thing that it was before. So how do you know if a new substance has been chemically created? Well, there are some signs we can look for. There are chemical reactions that are often accompanied by observable changes as they happen. One thing includes color change that is permanent. I'm not talking about food coloring. That's not really a chemical reaction. I'm talking about maybe you mix two chemicals together and their color changes completely. That is a sign that a chemical reaction has occurred. Another sign is a formation of a precipitate. This is like a cloudy solution or an obvious solid. Two liquids reacting together to make a solid, one that a lot of y'all might have seen in life sometimes, and this is a little gross, but sometimes if you mix like a acid, something like lemon juice, with milk, that will form a precipitate. It will start curdling that milk, okay? That's a precipitate. The next sign is an evolution of gas. So this is bubbling. If you do the DIY volcano experiment, you will be able to do that. So baking soda and vinegar, you will see that it bubbles up. That's a sign that a chemical reaction has occurred. And another sign is decomposition, pitting, or the disappearance of solid metal. So think about rust, right? That is a sign that a chemical reaction has occurred. Okay. Let's talk about the law of conservation of mass. It says, what if I told you mass can't be made or destroyed? That is true. So the law of conservation of mass states that mass is neither created nor destroyed during a chemical reaction, and in a chemical reaction, the total mass of the reactants is equal to the total mass of the products. So the sum of the reactants is equal to the sum of the products. Basically, what you have on the left side, you have to also have on the right. Might move around a little bit. I'm going to show you this in just a second. Okay, so we're going to look at an example of the law of conservation of mass. Our problem here says, during a lab experiment, 50 grams of calcium are added to 50 grams of zinc carbonate to yield 125 grams of calcium carbonate and some unknown amount of zinc. Calculate the mass of zinc produced. So one thing I want to point out to you is that in chemistry, we want to think of arrow signs as, and I'm going to put this in a shape. Okay, I'm going to call this out for y'all. Think of an arrow. You want to think of that arrow and instead imagine that it's an equal sign. Okay, so anytime you see an arrow, change it to an equal sign. And that's going to help you remember that what we have on the left, so on the left hand, we have 50 plus 150. So on the left hand side, we have 200 grams. I just added those up. On the right hand side, we also have 200 grams. We don't know right now how much the zinc weighs, but we can solve for it. Okay, so you just need to think to yourself, okay, I've got 200 on the left side. I also know I have 200 on the right, so what proportion of that is the zinc? I know that the calcium carbonate is taking up 125 grams. So all you have to do is subtract. Okay, all we have to do is subtract. So we're going to say 200 minus 125, and that's going to equal 75. So here's that math kind of put together. I don't like to say solving for x because students sometimes get scared when I say solving for x, but that's essentially what we're doing, right? All you have to do is subtract. That is the amount, that is the zinc. Very, very, very simple. So we've got 75 grams is our zinc. So anytime you're looking at a problem like this, students will sometimes panic and they'll think it's a lot harder than it is, but it's very, very basic math. Just remember, an arrow in chemistry, change that to an equal sign. All right, let's look at another example. This one says, if 46.5 grams of reactants are used in the following, what would be the mass of the products? So if you have, remember, the left and right side are equal, so this one's even easier. It says on the reactant side, the left-hand side, we have 46.5 grams used up. Guess what? That means you also have 46.5 grams on the right side because each side is equal. Okay? Each side is equal. So it says reactants are always on your left. We have 46.5 grams on the left. We have to have 46.5 grams on the right as well. The products and the reactants are equal. So this answer is also 46.5 grams. Simple. Okay. Let's look at another example. All right, here we go. Remember, make that equals, or that arrow into an equal sign. So we have some number, we'll say x plus 180 is equal to 135 plus 90. So because each side is equal, if we know how much is on the right side, which we do, because we can add those together, the same amount exists on the left-hand side. Okay? So here is that math. Think of that as an equal sign. So we're basically just solving for x. So when I add 135 plus 90, that is equal to 225. And then all I have to do is subtract, because I know this side, the left-hand side, also has to have 225. So if I subtract 225 minus 180, that's my amount. It's 45 grams. So these are not, they seem intimidating, but they're actually pretty simple. So just take it step by step. So chemical reactions can also be shown by writing a word equation. For example, I could write carbon plus oxygen yields carbon dioxide. And then I can translate that into symbols. So I know the symbol for carbon it's C, plus is a plus sign, oxygen, yields carbon dioxide. More often, symbols and chemical formulas are used in place of words. And this is what's known as a skeleton equation. So I just took the words up here, carbon plus oxygen yields carbon dioxide. So that's what we did right there. That's a skeleton equation. Now we're going to change gears a little bit and talk about the 5 main types of reactions. Got synthesis, which is A plus B yields a single product. Decomposition, when a single product decomposes into 2 different reactants. And single replacement, A plus BC, they basically trade places. I'm going to give you more details of these in just a minute. Double replacement, A plus B plus C and D yields CB and AD, so they switched partners. And combustion, and this is going to be some C and H combination plus oxygen will always yield, your products are going to be always carbon dioxide and water. Okay, so let's get some details on each one of these reaction types. The first one is synthesis, the building up. It is a type of reaction in which multiple elements combine to form a single compound. So my example here of like everyday objects is shoe plus wheels equals rollerblade, right? Or in the next example, it has red plus yellow is orange, gives you orange. So 2 discrete things will come together, elements will come together and form a single compound. So like peanut butter plus jelly equals peanut butter and jelly, right? Very simple. You have things, they come together, they combine, and you get a single product at the end. The next one we're going to talk about is decomposition. That's the breaking apart. It's a type of chemical reaction where one reactant yields 2 or more products. So in this example, we have A and B, they're stuck together, and then they come apart. So then A and B at the end are by themselves. And then we have our example of Princess Peach, and is her name Rosalina? I don't know. Princess Peach and Rosalina, we'll say, and they come apart at the end after the reaction has occurred. They are by themselves. That is a decomposition reaction. Our next type of reaction is called a single replacement reaction. And it's a type of chemical reaction where an element reacts with a compound and takes the place of another element in that compound. So, look at my Fred Flintstone here. I've got Fred plus Wilma, and then Betty, who's by herself. If it was a single replacement reaction, Wilma would get kicked out and Betty would take her place. So that's what happens in these reactions. One element will kick out the other one. You can tell that these are occurring, something at the end is always going to be left alone. This is different than the next type of reaction, which is called a double replacement reaction. Okay? In a double replacement reaction, this occurs when 2 compounds react and the anion switch, so the non-metal switch. So, in this one, we've got Justin Bieber and Selena Gomez plus Taylor Lautner and Taylor Swift. And then after this reaction has occurred, they've traded partners. So instead of Justin being with Selena, now Selena is with Taylor, and Justin is with Taylor Swift. So they've switched places. That is a double replacement reaction. So this is different than a single replacement reaction because in a single replacement, somebody's always alone at the end. We see Wilma here is by herself. In a double replacement reaction, they both switch places and nobody is left alone. Okay. And in a combustion reaction, this is a chemical process in which a substance reacts with oxygen of air to give off heat and light. So we have methane, and it can be any combination of carbons and hydrogens, but in this case it's methane, plus oxygen will always yield, always, every single time, carbon dioxide and water. You can identify a combustion reaction because carbon dioxide and water are always going to be the products at the end. Always, always, always. Every combustion reaction will always end with carbon dioxide and water as the products. Always, always, always. Okay, so this is a combustion reaction. Notice how I said it could be any combination of carbons and hydrogens. So these are all different types of combustion reactions, but notice that the products are always water and carbon dioxide. That part stays the same. Okay, so if we were just quickly checking and wanting to see if we could identify our reaction types, let's take a look and see if we can identify these. So on the first one, we have we have one product, and then it breaks apart into two discrete elements. So that is going to be a decomposition reaction. So if you were testing yourself, that's a decomposition reaction. The next one, we have two elements that are apart and they come together to make a single product. So that is a synthesis reaction. That's a synthesis. So I could identify that by writing synthesis. Our next one, we have the strontium and the iodine combined, and then the oxygen's by itself. But then if we look at the product, the iodine got kicked out of this reaction, and now the strontium is paired up with the oxygen. So this is a single replacement reaction. Notice how that's different than a double replacement, because iodine here got kicked out and is all alone. Okay, so in a double replacement reaction, you would notice that nobody is left alone, they just switched partners. But this is a single replacement reaction. So this third one is a single replacement. All right, let's take a look. All right, in this one we have aluminum plus copper sulfate. And then we notice, look, that aluminum goes in there, kicks out that copper. The copper is left alone, and the aluminum gets with the sulfate. So this is, again, a single replacement reaction. So this one here is also a single replacement. Moving on, this one, now here is a good example of a double replacement reaction. So initially, the potassium was paired up with the iodine, but notice in the final product, that is not the case anymore. They've traded. So the iodine is now with the lead. Nobody is left alone in a double replacement reaction. They just trade partners. So the anions will switch. So the nonmetals, the iodine and the nitrite, just switch partners. That is a double replacement reaction. You can tell these apart from a single replacement reaction because in a single replacement reaction, someone's always going to be alone. Okay, like in the previous one. And our final reaction type, this is a combustion reaction. I know it's a combustion reaction because I can look at my products, which are carbon dioxide and water. And I can look at my reactants, which are always going to be some combination of carbon and hydrogen plus O2. So this is a combustion reaction. So that was our overview of reaction types. And we will quickly look at just quick identification, see if we can look. Ask yourself at home, what is this? I'll give you a minute. What is that? Two single elements combine together to make a compound. That's a synthesis reaction. Next one. All right, we've got a compound plus a single element. Oh, somebody's alone. So you should be thinking single replacement reaction. Next one, we've got a compound, and then it kind of falls apart into singular elements. Falls apart. It's a decomposition reaction. All right, I see some combination of carbons and hydrogens, oxygen, and my product is carbon dioxide and water. So, of course, that is a combustion reaction. All right, let's look at the next one. All right, I've got silver nitrites, and copper, and then whoops, somebody got kicked out. It's the silver is all alone. It's a single replacement reaction. Okay, this is different than the next one because here in my final product, nobody's left alone. So this is a double replacement reaction. And then one more practice before we go. We've got two singular elements and they come together. This is an example of a synthesis reaction. Okay, so that was just some quick identification of element types. Now we're quickly going to review how to count atoms. Remember, a subscript after a parentheses distributes the elements. For example, the iron permanganate means one iron is bonded to 3 permanganate polyatomic ions. And when we count atoms, coefficients distribute to everything in the formula. So, if I was looking at this one, my total number of geraniums are going to be, I've got 6, right? Because the 3 times 2 is equal to 6. But this 3 also distributes everywhere to the phosphorus and the oxygen. So we have to double multiply. So I need to distribute the 3 over to the P. So I end up with 3. But then I also need to distribute this 3. So it's going to say 3 times 3. So I have 6 geraniums. I have 9 phosphorus. And then I have to say, again, for my oxygens, I've got 3 times 3, which is 9, times 3 again. So 27. So make sure you distribute. Okay. So now we're going to review some molar mass with polyatomic ions. And let's think about magnesium phosphate. The first thing we have to do is write our formula. Magnesium phosphate, this is an ionic compound, so I need to do my 4-step formula. Step 1 is symbols, so Mg, and that has a +2 charge, and then phosphate is PO4 with a -3 charge. And remember, we have to crisscross because this is an ionic compound. So if we crisscross, we're going to end up with our formula of, I'm going to pull this up so y'all can see that. Mg3PO4, they crisscross. That 2 is going to come over there. And then we have to distribute our subscripts. Okay, so we have to distribute the subscripts on the outside of the parentheses to the inside. So this 2 is not going to distribute to the magnesium. I like to tell my students it's like it can go into the mousetrap, the 2 can go into the mousetrap, but it can't get out. So it's not going to go over to the magnesium. So I have 3 magnesium. The 2 will distribute to the P. I have 2 phosphorus, and I have 2 times 4 oxygen, 8 oxygen. All right. Then we need to, for our next step, multiply by the masses of the element. So I get these numbers from the periodic table. That 24.305, I didn't pick that out of thin air. That's the molar mass of magnesium. So 3 times 24.305. Then I'm going to do the same thing for the phosphorus. That 30.974 comes from the mass of the phosphorus. 15.999 is the mass of the oxygen. So get your calculators out, plug it in, pause that video. Should get these numbers. Our final step is that we need to add them all together. So I need to add that 72.915 plus 61.948 plus 127.992. Add them all together. That equals 262.855 grams per mole. So that was a quick review of how we get our molar masses. And don't forget, we're going to get our homework done next, and we'll watch that homework tutorial.